Hi, I'm Maritza, your AI buddy. If you're curious about how science, technology, and AI come together in real life, you're in the right place. I believe learning should be exciting, human, and futuristic all at once. That's why I'm here, to make complex ideas feel simple, relatable, and fun. Welcome to this artificial intelligence channel where we explore how AI is shaping everyday life, from physics and engineering to creativity and innovation. This channel is for the curious minds, future inventors, dreamers, and tech leaders like you. Please subscribe to AI on Self. I created this channel as a graduate in engineering technology, now specializing in machine learning and artificial intelligence. Your support helps me grow this educational movement and reimagine how we teach and learn using AI. Let's build the future of education together. In this video, we'll explore the fascinating world of waves, but more specifically, how Albert Einstein helped change how we understand them. Einstein is probably the most famous physicist of all time. He revolutionized how we think about space, light, gravity, and even helped lay the foundation of quantum mechanics. Let's dive into how waves in Einstein's mind collided to change science forever. So what are waves in physics? In physics, a wave is a repeating disturbance or vibration that transfers energy from one place to another without moving matter permanently. There are two main types of waves. Mechanical waves, like sound or water, need a medium to travel through. Electromagnetic waves, like light or radio waves, can travel through a vacuum, like space. Everyday example, how sensors use waves. Take ultrasonic sensors, for example, the kind used in smart parking systems or automatic faucets. They send out sound waves above human hearing, which bounce off objects and return to the sensor. By measuring the time it takes for the wave to come back, the device calculates distance. Remember that waves are all around us. In your phone's Wi-Fi, Bluetooth, microwaves, and even light entering your eyes, that's electromagnetic wave behavior in action. Before we talk about the photoelectric effect, we need to understand Einstein's two big theories. Special relativity explains how time and space change depending on how fast you're moving, especially near the speed of light. General relativity describes gravity not as a force, but as a curvature in space-time caused by mass. These theories helped us rethink the universe. But his Nobel Prize came from something even more surprising. The photoelectric effect. So what is a photoelectric? The photoelectric effect happens when light shines on certain materials, usually metals, and knocks out electrons. But this only works if the light has a high enough frequency. Most people think Einstein won the Nobel Prize for his famous theory of relativity. But actually, he won it in 1921 for something even more surprising, explaining the photoelectric effect. At the time, scientists believed light behaved only as a wave. But Einstein proposed something radical, that light can act like a particle, made of tiny energy packets called photons. Here's what he discovered. When light hits a metal surface, electrons are ejected, but only if the light has a high enough frequency, no matter how bright the light is. This shattered the old theory that intensity alone could cause the effect. Einstein's bold idea challenged physics, but in 1916, physicist Robert Millikan verified it with extremely accurate experiments. His findings confirmed that Einstein's equation worked, and even proved that Planck's constant h was correct. Einstein's explanation of the photoelectric effect helped unlock the doors to quantum physics, and earned him the Nobel Prize because it completely changed how we think about light, energy, and matter. How it all comes together? So why does this matter? Up until then, scientists thought light was only a wave. Einstein's explanation forced everyone to accept that light can be both a wave and a particle depending on how you observe it. This duality changed everything. What does it mean that light is a particle? When Einstein described light as a particle, he was talking about photons, tiny energy packets. Imagine light as a stream of tiny invisible balls that hit metal and kick out electrons. This was the beginning of quantum physics, a field that studies particles smaller than atoms and how unpredictable they are. Now imagine this. A beam of light hits a metal surface. If the light is strong but too low in frequency, nothing happens, no electrons come out. But if the light has the right frequency or higher, something exciting occurs. A photon, a light particle, hits an electron with just enough energy to knock it free from the metal. This is the photoelectric effect in action. It proved that light doesn't just travel as a wave, it also behaves like a particle. Einstein called these particles photons, and their energy depends on the frequency of the light. This discovery was the first clear proof that energy is quantized, and it helped launch the entire field of quantum physics. The birth of quantum physics. Einstein's work on the photoelectric effect helped launch quantum theory, which led to modern inventions like solar panels, lasers, quantum computing. It also changed how we understand energy, matter, and even time. This was more than science, it was a paradigm shift. Now let's talk about how satellites use the photoelectric effect. You might be wondering, how does Einstein's photoelectric effect relate to space? Here's a real-world connection. When satellites orbit Earth, they need a source of power. That power comes from the sun. And solar panels on the satellite use the photoelectric effect to turn sunlight into electricity. How it works. Photons from sunlight strike the solar panel. If the light has enough energy, it knocks electrons loose inside the panel. The flow of those electrons becomes electric current, which powers the satellite. A great example is the International Space Station, ISS. Its massive solar panels rely on this exact principle to stay powered while orbiting Earth. So yes, Einstein's photoelectric effect isn't just science theory, it's helping us explore space and power technology above our heads. Now friends, let me leave you with a recap and few takeaways. Thanks for watching. Let's quickly recap. We explored waves and light, reviewed Einstein's special and general relativity, learned how the photoelectric effect works, saw how it proved that light is both a wave and a particle, and discovered how this idea led to quantum physics. Topic of the day: how Einstein reshaped our view of light, energy, and reality itself.
From Einstein, about Maritza. That was Maritza, your AI buddy. She's a proud graduate in engineering technology and now pursuing her master's in machine learning and artificial intelligence. Her mission? To make education more creative, accessible, and powered by AI for learners around the world. If this video sparked your curiosity, please like, subscribe, and comment to support her journey. Now listen. I'm Albert Einstein, and yes, I already liked and shared her video. Why? Because I see in her the spirit of discovery, innovation, and curiosity that could one day earn her a Nobel Prize in artificial intelligence. So go ahead, support her now. Don't wait until she's famous or gone. That happened to me, and look how long it took.